So at first I will explain about the encoder of the system. So basically for the program, we first will define the sampling frequency of 8000 with a duration of 0.5 seconds for each pair of tone. So we then need to define the frequency value for each tone pair. So for each row, it will be a row of the frequency, and for the second row is the second frequencies. So basically for the for loop, we need to generate 0 to 3 means total of 4 dual tone signals. So this is the formula need to generate the dual tone signal for current number. So it's the cos 2 pi, then our frequency values times the time vectors. So then we need to plot the signals and generate the sound. So this is the desired limits we set to the x-axis and also y-axis. So to limit its axis of value to show the amplitude more clearly. So then finally we input a sound command to hear the voice of the tone pairs. So now we'll see how this function works. So basically, you'll see that each tone pair with different frequency will show different amplitudes of the tone pairs. Yeah, so each tone pair will have a 0.5 seconds of playing times between each tone pair of frequencies. So this frequency will store inside a function, and you need to decode them back to the digit numbers accordingly. So first we assign each tone pair assigned as 0, 1, 2, 3. So we then need to decode them back to the digit numbers. Then we move to the decoder part. So decoder part is same. We first clear the frequency first. So the frequency has been declared, and we need to use a function of decode frequencies. So the main function in this script is like the decode message, where you will take the matrix of the frequency as an input, and each row will represent a pair of frequencies. So the function will iterate over each pair, like 325 and 755, 415, 880, 520, 917, and finally 645 with 1085 Hz. So you will then decode them into a digit using these decode frequency functions. So then the decode frequency function will take two frequency of F1 and F2 as input and determine their corresponding digit based on their pair of frequencies. So it will compute, then for next it will compute the difference between the input frequency, and also we predefine the set of frequencies. So and also we need to select the index with the minimum difference. So the resulting index is used to determine the digits. Then finally, for this part is used to generate the waveform. And so we need to apply the filters to make them to pass only a certain frequency which meet our requirement of frequencies. Then this command is need to plot the frequency spectra. We need to generate back the origin frequency amplitude. We also, same as the previous example, we need to set the limit of it, and also need to display the decode message to show that the function is successfully decoded back into the digit number. So this is the filter tone based on our frequencies. So we need, as many conditions, we need to declare according to our frequency and also the filter order. And finally, this is the Nyquist rate we need to calculate. So filter the tone. So now we need to analyze the output of the decoders. So we need to run the functions. So as you can see, there is a total of 4 frequency spectra they generate by tone pair 1, 2, 3, and 4. So for each tone pair, they will have a symmetry output, means the high in amplitude. So this high in amplitude show that this is the frequency that we have set for each tone pair. So for the first tone pair is represented by 325 and also 755. So for the tone pair 2 is, as we can see, is 415 and also 880, around 880. So for the third tone pair is 520 around and also 917. And for the last tone pair, the appropriate frequency we set is 645 and also 1085. So this frequency spectra will show that we have successfully decoded the digit number back to its desired frequencies. So we can now move to the command window. So as you can see, this shows that the function has successfully decoded in 0, 1, 2, 3. Now let's say if you want to change the sequence of the digit of number like 3210, so we can change the arrangement of the matrix of this tone pair frequency. So by upside down the frequencies. So the others will be the same. So now let's see the result. So now you see each frequency spectra has changed to their desired frequency. So if this sequence of digit number is 3210, so means that first tone pair is the combination of 645 Hz and also 1085 Hz. And so same to the remaining one is 520, 917. This one is 415 and 880. And this one finally, this one is 325 and 755, around that value. So now we see the command window. You can see that the system successfully put into the sequence of 3210. So this is basically the working of the encoder. First need to encode the pair of frequency, then store them, and also then we decode back and get the same origin frequencies using these two. Yeah, that's all. Thank you.